All right, this is the beginning of part two of the lecture on tools and equipment use. So where we left off last was talking about mechanical means of cutting. We had mentioned about cutting and machining and sieving, filtration and sedimentation. So we can also now talk about centrifugation, where we basically put stuff through and spin it using centrifugal force to get the heavier compounds to kind of move to the bottom or underside of that, and the lighter components move to the top. There's another separation process called winnowing. I was just watching a video on the way Reese's peanut butter cups are made the other day. They raw peanuts. They kind of, as they're roasted, after they're roasted, they have that little thin membrane, that reddish membrane around the peanut that kind of flakes off, and Reese's and Hershey basically uses the process of winnowing, which is air current, to blow those light pieces of away from the actual peanuts before they go and start to pulverize and crush them to make peanut butter. So then that's a process called winnowing. We also can use magnetic separation, where we kind of use a magnet and pull anything that has a magnetic iron ores in it, and is magnetic. We can use that to separate stuff. And then, of course, we always can just sort stuff by manual sorting material based on particular properties, color, density, or shape as well. We get into the chemical means of separation. We talk about distillation, so where we're bringing things up to boiling points, basically boiling the water away, and we are left with the remaining part of it. We can also talk about evaporation, where we just kind of let it slowly evaporate away, so leaving any solid behind. Talk about crystallization, so where we are using some type of a chemical reaction to form crystals there as well. Again, filtration is also done in this regard. Same thing with sublimation. We can do decomposition, or we can do electrolysis here as well, where we're using electricity to force some type of a spontaneous chemical reaction. Now, these, of course, are all chemical related and would require different types of degrees to be able to kind of do this. If you think back to your chemistry labs, either in high school or even at college, you're probably familiar and have done most of these different processes in a chemistry lab at some point along the way. So if we talk about some different separating tools, mechanical means, of course, are chisels, punches, saws, drills, drill presses, mills, lathes, and plasma cutters. Most of those you're probably familiar with at this point, or have used at some point in time, with maybe the exception of the plasma cutter and the mills and lathes. Of course, if you are in the engineering tech program, you will get some hands-on experience using mills and lathes as well, and you've already gotten some practice using drills and drill presses and saws in this class. Next, we're going to talk about forming tools. So forming is basically where we are using and shaping material either by bending, twisting. We might roll it, we might compress it, and form it into the different shapes that we want. So if you think about some more recent technology, especially in terms of ejection molding, we can take plastic, liquid plastics, inject it with pressure into a mold. That mold, basically, the plastic then forms the shape based on the mold that it's left, and then, of course, we can remove that from the actual mold as well. So if we talk about bending, so you guys have had some practice now using the brake, and of course we use that brake to bend or twist material into shapes that we want there as well. Combining tools are where we're putting different components together. So if you think about these can also be either chemical, mechanical, or thermal. So if you consider what we talk about and what you're doing when you're welding or brazing or soldering, you're adding different elements and putting things back together. So those would be some of the different types of combining tools that we would be looking at here as well. We get into conditioning. Conditioning is a way to change the properties of the material that we're working with. So usually that's not something that you can see, although sometimes you can tell, especially in the heat treating system. And you guys will see we have bent your S hooks. So you bent both two types of material. We bent some stainless steel, making the S hook, and we also bent some aluminum. You notice the differences between the two. And you also at this point should notice a difference in color, a difference in the look of those two materials. Now we're going to do a heat treatment to some of that material, and you'll notice a color change come out of that as well when we bring it out. And that's going to be kind of that heat treatment where we can use to either harden the material, make that material harder. We can temper or anneal it. Basically, tempering is going to bring it back and kind of bring it back to a softer state. Same thing with annealing. And we do all of these different things for a variety of different reasons, depending on what the mechanical properties and what type of use we're looking to get out of that material when we're finished. If you think about tempering glass, so that makes it stronger. Of course, fuyao would be tempering glass as well, so that makes it a little bit stronger and not as likely to shatter on you. Or if it does break, usually tempered glass will just kind of where you get all that spider webbing more or less in the glass, where as opposed to all the shards and pieces that are breaking away. So a lot of these conditioning methods are ways that we use to prepare a surface there as well for any type of additional finishes too. So there's a process called carburization that usually brings carbon to the surface. That's used oftentimes to condition material for additional surface finishes as well. So talking about coating and finishing, so we can talk about dipping or spraying or plating, so electromagnetic plating and powder coating, or just regular paint as well. Caterpillar, of course, has their paint booths where they apply paint to help as rust inhibitors. We do have other methods of galvanization or uh, anodization there as well that are coatings or finishes that would kind of allow the material to be built up. In this case, we could talk about chrome plating too, where you're going to build up the surface of that, and usually done for a variety of different reasons there in the manufacturing process as well. This is just a couple of glances of some common power tools and hand tools that are out there. So you should be familiar with most of these. So notice some of the differences between these. The relationship before, like I had mentioned before, usually for every hand tool, there's some type of a power tool that would kind of be related to it. So kind of keep that in mind. Most of these depending on what material you're working with, whether you're working with woods, plastics, ceramics, metals, that is also going to have a relationship with what type of tool you're going to be using to take care of and work with that material that you're working with. Here's a couple more pieces of machinery and tools. So some heavy duty machinery for the metal cutting industry, as you can see up here. So some over on the right hand side, the picture here is more woodworking type power tools and equipment that you would be using in the woodworking industry. Of course, you have this combination shear, brake, and roller. Finger brake here that we also have in the lab and you use to make your fabrication project there as well, and got some practice with using that tool too. We don't want to forget about using different types of material handling equipment. So these are valuable tools too. So scissor lifts, regular lifts, our jibs and cranes, power lifts, dollies, hand carts, go-kart. All of these are valuable tools that help us perform work and lighten our load. So it's a way for us to lift or move heavier objects that we wouldn't necessarily be able to do by our sheer power and strength alone. So these make it easier for us as we go. We're going to talk now a little bit about computers in manufacturing. I would be remiss to not mention in my 30-year career, computers have played a main part in everything that I've done. So, and whether it comes down to just kind of recording your timesheets when you clock in and clock out, or pulling data, signing into jobs, so that all of these tasks that the manufacturers nowadays use are all kind of kept records and documenting data, controlling equipment in our modern day production facilities. So you need to become up to speed and computer proficient here in the 21st century as we use computers in manufacturing. So, and of course, for me in the Sim Lab, that of course is the name of the Sim Lab in computer integrated manufacturing. So, how we use those to control our manufacturing processes, how we write programs for the machines, how we, and that could be just our computer numeric control machines on the CNC using G code, or it might be talking about ladder logic or PLC or other types of automation devices there as well. So now that you've gotten a pretty good overview of that, let's talk about how you're going to be using these tools on the job. So you are going to have to get familiar with the tools that you need to be effective and efficient and productive. So you're going to need to be able to set up, test, and operate equipment. So you're going to need to know what some of the equipment and the alarms and the sounds that the tools are making when you're using mean. So you might need to be able to monitor and maintain equipment by reading dials and gauges and understanding what those are all about. So with instrumentation, that way you can diagnose different problems or anticipate or problem solve before problems actually occur. So we need to be able to make sure that we know and understand how to use and everything that's going on with that equipment. So and those tools. So every day when you start, you should kind of make sure that all of your tools are in good working order, inspected, that they're clean, that they've been taken care of, that they're ready to go, so that you can get your work done safely and efficiently that day. Even in here, as you're taking a look at some of our hand tools, especially hammers and dead blows, and the mallets, always double check. Sometimes the head of the mallet or dead blow might be loose to the handle, so we don't want to use that. If you do come across any of those tools that are in bad condition, please bring them to me and make me aware of them so I can take them out of service and either choose to repair or replace those tools as well, so that nobody would get hurt should the head of a hammer or come off, or a screwdriver or something else is damaged. So when we are working with these tools, obviously stay aware of all the current practices. Make sure that you are reading up. Oftentimes, especially on new machines and equipment, you might be expected to be the one to get that up and running on your own, having to do your own work there. So make sure that you're reading the training manual or reading the actual the actual equipment manual that comes through, so you know everything that you need to know about that particular machine. So another way that you can stay up to date and current is just by making sure that you're reading trade journals. That would be on there. Those trade journals going to help you to make suggestions, improve your job performance, and overall leave better impression that you are in basically becoming a master of the trade in your area, fully knowing and understanding the tools, and have a good grasp and command of the use of all of those tools as well. Lastly, we're going to go over different job specialties here. So, and then I'll come back with the third part of this. So I'm going to finish up on this slide with this video. We're going to mention the different types of job specialties. So I know many of you are in here and maybe already have an idea of what you want to do and how you want your career to proceed. So kind of think about that. If you don't, now's a good time to kind of consider what you need to be doing to prepare yourself. Some of the job specialties, of course, is a machinist, a machine setter, machine operators, computer programmer, whether that's G code on CNC or ladder logic or other types of PLC in the electronics lab. So you need to be able and be proficient with that. And of course, we're going to come through here. And so we're going to talk more specifically now about the maintenance specialist and the importance of the maintenance specialists here in our tools and equipment use as well.